Hello and greetings from Steep Coffee Shop in Denver on a very cold and blustery day. There's actually a little bit of snow in the trees above me. Hopefully it will not fall on my head as we're discussing acids and bases, because that would make me feel sort of caustic, you know, because it's all about the base, no acid. So, all right, let's dive in. Acids and bases, here we go. Properties of acids. An acid is a substance that produces hydrogen ions. In this case, it is a cation, H positive in solution. Remember, that means that it has more protons than it does electrons. So it is overall H positive. All right, so the properties. It's going to taste sour. It's corrosive, which means that it eats away metals and also burns skin on contact. It has electrolytes in it, which means it can produce electricity because, again, it contains positive ions. And it will also react with indicators, things like cabbage juice, phenol red, things like that. All right, so an indicator, what that is it's an organic compound that changes color in either an acid or a base, depending on the presence or absence of, in this case, hydrogen ions. All right, so like I said, an example is cabbage juice, litmus, hydrangeas, lichen, or phenol red. All right, so some common acids. A common acid is found, it's pretty prevalent. It's found in everyday items, such as food, like citrus, lemon, things like that. Also in your stomach, it helps to break down food. We'll call it stomach acid. All right, also in car batteries, some household cleaners, some common acids are sulfuric, H2SO4, and hydrochloric, which is HCl. All right, so properties of bases. A base is a substance that produces hydroxide ions. This is OH negative, which means that, remember, it is overall an anion because it has more electrons than protons in the nucleus. So it is going to make the overall charge a negative. So OH negative hydroxide ion. The properties of a base. It tastes bitter. It feels kind of slippery. Also corrosive, also has electrolytes. That was a little bit of snow that went by. And again, just like the acid, it will react with indicators. So it's common bases. Common bases found in everyday items: deodorant, antacid. Some common bases are going to be ammonia, NH3. This is used to make household cleaners. Sodium hydroxide. Also known as lye, which is actually what they used to make soap back in the olden days. Like I said, used to make soap. It's bitter and slippery, and also lye is also found in drain cleaner. All right, if it's neutral, that means it has a substance that has a balance of H positive and OH negative in solution. So in this case, water. Strong versus weak. Okay, so not all acids and bases have the same strength. A strong acid is where more molecules break up into H positive ions in solution. So that means that there's going to be more hydrogen ions in the solution. It produces more H plus. So for instance, hydrochloric acid is going to have more H positive ions in solution. If it's a weak acid, that means that fewer molecules are actually going to break up and head into the solution. So vinegar is actually a weaker acid than hydrochloric acid. All right, strong base. Same deal. So a stronger base has more molecules that break up into the OH negative ions in solution. So again, they produce more OH negative in that solution. So for instance, in this case, sodium hydroxide, a weak base is where fewer molecules break into OH negative ions. In this case, ammonia. All right, so strong and weak acids and bases refer to how easily the acid or base breaks into individual ions in the solution. All right, so concentrate versus dilute. So a concentration is the number of particles in a given volume. Concentrate, if it's concentrated, as the name would suggest, it has lots of particles in the solution. It's pure. Now, obviously, if it's concentrated, opposite of concentrate versus dilute. If it's dilute, that means there are few particles in the solution. It's diluted. It's kind of watered down. All right, so pH of a solution. The pH, parts hydroxide, measure of the concentration of OH negative ions in a solution. pH comes from parts hydroxide, OH negative in this case. So the pH scale is a series of numbers from 0 to 14, and actually sometimes you will find pH scales that go on a scale of 0 to 12. Not a huge deal, just still the same basic principle, they just don't quite go up as high as 14. So lots of OH negative equals base, and lots of H positive ions equals more acidic, it's an acid. If it's lower than 7, it's acidic. 7 is neutral, so in this case water would sort of be the middle. If it's higher than 7, that means it is a basic. So 7.1 is slightly basic versus 14, which is very basic on the scale. All right, so example, rain is 5.8. Seawater is going to be 8.9, which means that seawater is actually going to be more basic than rain. All right, so here is a pH scale, kind of runs you through from massively acidic, is going to run you battery acid, sulfuric acid, then goes lemon juice, vinegar, on down the line. Sort of the middle ground is going to be water. Milk is pretty close to it. As we head down into the more basic, we have bleach and liquid drain cleaner. Oh, there's some good snow. A little bit of sun, a little bit of snow. All right. Actually, it's not doing very much for my computer. All right, so let's hope we don't have like an electrical short. Yeah. All right, here we go. pH scale. On this end, we've got a strong acid of 0. Going to be 7 in the middle. And again, this is going to be based on a 14-point scale. Obviously, on this end, we're going to have a strong base at 14. So we're going to have a weak acid, weak base, just on either side of the neutral of 7. So your acidic range is going to actually be 0 to 6.9, as 7 is neutral. So obviously on base, you're going to have a 7.1 to 14, which is going to get you the range for basic. All right, that is it. The sun has come out. I'm not feeling nearly as acidic as I was. So hopefully, I hope you like this. It is pretty basic. So we'll see you in class. Okay.